Hello and welcome back. In this episode, we are going to be implementing tile-based movement for our tile map. But I wanted to start with one of the things that I just kind of enjoy about working with this mini microsystem. There's if you go into the system sounds directory and see that there's a little fanfare wave file. So, file, load sound, sys sounds, fanfare, play. Ta-da! All right, now here we go. So here's what we're starting with. We have our little characters. We want to implement collision. There's a couple problems with this. One of them is let's say like this gap here is the exact size of the player's bounding box. So you would have to perfectly line up the player with the door to get through the door. And there's ways you can get around it. Like I've done it before. You can implement something where you hit the wall and it kind of slides towards the nearest opening. But it's hard to implement correctly. And then you would have to do something to I don't know. You'd have to do something weird to get the NPCs to walk around in a reasonable way. I've referenced the game Final Fantasy II on the Super Nintendo a couple of times, and it's basically the form of gameplay I'm trying to emulate. And in that one, everybody walks one tile at a time. You go slide, slide, slide. So you're always starting from a tile, which means that whenever you get up to a door, you are going to definitely be aligned with it and just be able to slide through. So that is the first step, is getting that movement set up correctly. And after that's set up, all we have to do is make sure that the player's tile coordinate or the target tile coordinate is walkable. We're going to be checking against the collision layer in the tiled map and a character array, entity array in the source code. So if we go back to our tiled map, there it is. Yeah, you can see I drew in all the places that should not be walkable, and we have another layer with all the entities. So we need to check both of those for collisions. But first things first, let's get the movement working correctly. So we will not be working, should not need to work with the tiled map again today. We're flipping over to our source code now. So the way this needs to work is every entity, whenever you move, you're going to be moving by basically the number of pixels equal to pixel width of that entity. So what this means, we're going to have to change the way this works. Right now, we're just grabbing the horizontal and vertical axes and adding that to the current position, which is not going to work anymore. It's fine for pixel-based movement. It's not fine for tile-based movement, but we can still use those axes. So if delta y is less than 0, which means that we are moving towards 0, which is down, let's go ahead and implement all four directions. Okay, if the delta y is less than 0, now we'll start with the simplest case. It's not going to look good, but I want to show you anyway. Mat point unit y times, I think I think there's a tile size. Oh, let's look at our constants again. Tile size in pixels. That's what we care about. gate it, and then move it by that tile size in pixels. Which basically means we're going to tell it to move down. And do something similar for all four directions. Don't negate the positives. And these two we're working with X. So this will technically do what we're wanting. We still, if either delta X or delta Y changed, we want to go ahead and update the scroll. So let me show you what that does. Quit, reload, and basically what it does is, as long as you're holding it down, it's moving by one tile at a time, which is like really quick movement. But you can see wherever our player happens to stop, it is right on a tile, which is kind of what we want, but not exactly. So what we want to do is give every entity the ability to set a target position. Sure, we can do this. I think I added a 0 to the point class. Let me double check. Go to math, point, 0. Yeah, we're just going to use that. So, start position is 0, target position is 0. If you're going to do a move to, God, we're not using that position anymore. We're using the sprites X and Y, which, you know, it's kind of nice. So we're just going to pull out position. So when you're doing a move to, you move the sprite and you set the self target position to that point. Ta-da! But when you're moving by, we're not going to want to. We don't want to recycle the move to anymore. We want to do something different. Self target position equals, make a point out of the sprite and then add the delta, and that's where we're trying to move to. Is that what I want to do? Let me think. I think it is what I want to do. And then we're wanting to do an update. Delta time is always measured in seconds here. But I'm going to make a note because in other systems it's measured in milliseconds, and I'm going to forget. So we're looking at the update. Every time there's an update, if self I want to do this. Distance between the sprite and the target position. I do that with the point class. If I can't, then I need to. Looks like you can do it, but we need to add something here, like this. Point distance equals function other point. To get the distance between 2 points, you take self, subtract other point, and get the length. So when you're subtracting 2 points like that, you're creating a vector. You want the length of that vector. That is the distance between 2 points. Point. If distance is less than 1, then let's just do a move to. Self, move to. Nope. I'm trying to remember to not use unnecessary parentheses, but I'm still catching myself doing it. No, I think I actually do need it there because that's a function. Okay, sorry. Moving on. Self move to target point. So if you're reasonably close to your target point, just go ahead and finish the move. It's less than one, go ahead and jump it. Otherwise, well, it's greater than, if it's greater than, then what we need to do, the easiest thing to do would probably be to, we need that vector again, I think. Need to grab the vector and normalize it. Might still end up dumping the point class into the global namespace because typing math.point every time is starting to get annoying. So we're going to subtract that, and we want to normalize it. Can we normalize our point? We cannot. Well, not yet. To normalize a point, what you do is you take the current point and you divide by the length. Do we have a division? No, we don't. Oh. Multiply. Do we have a multiply and a scale here? That's kind of fun. Those are both the same thing. Are you using that scale anywhere? Well, not that function. And we're going to make the scale function go away because we don't need scale and multiply, and instead have it divide. Divide is like multiply, but we're dividing. Divide x and y by a value. So to normalize, self divide by self.length. Turn that, now we have a normalized point. So, and I'm actually going to do the distance function a little bit differently because there's redundant math in here, and you don't want to have a lot of redundant vector math. It makes your computer sad. So let's say that our vector is self tract sprite point is that. Just we'll make sure we only do that once. Subtract sprite point. Now we have the vector between the 2 points. The distance is the length of that vector, and then the normalized vector is vector dot normalize. And then what we now the way this should work, self sprite x plus equals normalized vector dot x self sprite y plus equals normalized vector dot y. So now every time you update the character, we're, we're gonna make we're gonna have to change this to take the delta time into account, but we will come back to that in just a few minutes. But if the target point is set, your character is currently moving, then we're going to start moving the character towards the target point, and we need to know if the character is currently moving. That basically is if self um, or equal. Hmm. There. We don't want multiple names for the same variable. Okay. You're moving if the sprite's position is not equal to the target position. Make sure the point has that function. Yes, it does. Cool. So now the way we use this, if we go back to main, player is moving, then we do all of our processing on the player. But then we are also going to need to do this. Sprite controllers update sprites. Does that? No, that just updates the sprite itself, not the entities. So player.update for delta time. Let's go ahead and throw our NPC in there too. NPC is called NPC. So there you go. Let's find out if that did anything. We're putting in it. Runtime error. Subtract's not found. Entity MS line 52. Self.subtract. That's not going to do. Self.targetPosition.subtract. That should help. More rogue parentheses. All right, try that again. No errors, but also the arrow keys do nothing. Very soon, I'm going to have to implement some sort of UI so we can get some sort of debugger going. And until then, we're just going to throw a bunch of print statements in there. Not player that is moving, print, I'm not moving. Well, that never happens. Let's make sure the print still works. Okay, see here we go, right up there. So, why does it think the player is moving? Is moving is 1. That's weird. Let's find out why. It's based off of the sprite position and the target position. Let's dump out both of those and see what happens. Point has a str function to convert it into a string. We'll make use of that. Print out the sprite position and the target position so we can just physically see what's going on. So we have another error here. Self is unknown in this context. Line 39. Let's see if we can get a better look at that. Stack trace. Self is unknown, line 39. Cool. So let's look at the source code again and see if we can figure out what's on line 39. And yeah, it's not going to work. Self is not a thing right there. We need to convert that into a string. It would technically print out anyway, it's just better formatted like this. Okay, restart. No errors yet. It is moving. Position is 800 by 1056, which is the same as the target. I think the bug is. I think. Yeah, we need a knot. That should resolve that problem. It was giving us the inverse from what we needed. Let's see if that fixes it. There you go. The problem is I can only do that once. Moved into place and then nothing. Interesting, because we should have accounted for that. Smooth. This is gonna be a little ugly, but I need to see the update on every frame. So you can see down here, the position is 863 on the X, and the target's still 864, and somehow the update is not accounting for that. Let's go into Entity Update and find out why. Print, let's just add distance. Really only want to update the player right now. We don't need the extra fluff on screen. Okay. Moving. Distance gets to 1, and then it stops. Checking if it's less than 1 or greater than 1, but if the distance is equal to 1, then it's not going to work. Rerun. Distance goes to 0, and now we're getting a little bit of a jump as our player moves around. It's fine, and it's because when we're updating the sprite there, it's not moving the camera. Now that problem can be fixed if we go back to main. We'll take our debug statements back out for a bit. Should camera move equals player is moving. Then we move the player, and then we will do the scroll. Okay, let's see what that looks like. And that's actually looking pretty good. We hold it down, player does just keep moving. And we'll just stop on the next tile. I'd like the player to move a little bit faster, but that part's looking pretty good, actually. That came together a lot easier than I hoped it would. Than what I had hoped for. See, I want the player to move a little bit faster. Let's see what happens if we take the player speed and multiply that by our normalized vector. That's working, but it's a little hard to hit one tile at a time. So I'm actually going to slow down the player a little bit. Player speed, currently 4. Cut that in half. Right, I can live with that. So I'm probably going to stop this video at this point and get all of that uploaded to the Git repo. Next round, we're going to handle actually checking the player's current, not the current tile position, because we know the current position is walkable. We need to make sure that the target position is walkable before selecting it. So now that will include refactoring our sprites a little bit. I'm going to put a couple of NPCs on the screen. We have one here. I want to be able to check against an array of them to see where everything's at. So we'll do those collisions next time. And then we'll work on seeing if we can get the NPCs moving around a little bit. That should be all kinds of fun. And that is all. See you next time.